Hi, everyone, and welcome to our on-demand session where we are going to share with you how to seamlessly leverage .NET on Ubuntu from development to deployment. Today, you're going to learn how Canonical and Microsoft are streamlining the .NET development on Ubuntu for .NET 8 on Ubuntu Enable. And if we move to the next slide, we're going to see that today, the 25th of April, the day we are recording this video, is actually the day we are launching Ubuntu 24.04 or Ubuntu Enable Numbet. And that's the reason why one of the topics in our agenda today, the first topic we have, is .NET on Ubuntu 24.04. We are also going to talk about chiseled and chiseled containers, .NET developers using Ubuntu, .NET demo. We're going to have a .NET demo, and also we're going to share some links in the end where we can learn more about all of this. Meeting our speakers, I'm Nara. I'm the first person here on the picture. I lead the Azure Alliances here at Canonical, and I'm in constant contact with the Microsoft teams. We also have Cristovao Cordeiro, who is the engineering manager here at Canonical for containers. And we also have someone from Microsoft. We have Richard Lander, who is the product manager for .NET, and he works very closely with us as well. So now I'm going to pass it over to Richard, who is going to talk a little bit more about .NET on Ubuntu 24.04.
Great. Thank you, Anara. So I'm going to talk about how you get .NET kind of installed and how you get going on Ubuntu 24.04. So we've been working, Canonical and Microsoft, we've been working together now for a few years, making .NET and Ubuntu work better together. And so let's start with .NET 8. So .NET 8 is available today with Ubuntu 24.04 launch in the Ubuntu archive. So the package is just called .NET 8, .NET 8. So it's just like any other package in the Ubuntu archive. And so you can see how you install it. You just apt install the .NET 8 package. And then once it installs, you can type .NET CLI commands, and then you're ready to do .NET 8 development. And that's really all there is to it. With .NET 6 and 7, it's very similar, except you have to register the .NET backports repository, and that's just one additional line. And then you can see there, you can just install .NET 6, very similar package name, just a different version number. And then after you've installed that, then again, you can use the .NET CLI and type .NET commands, and you can do your .NET development from there. I wanted to talk a little bit about servicing and support. So Microsoft and Canonical work together on security servicing. Everyone wants to keep their machines safe and their users safe. And so Canonical has access to security patches before they're delivered to the public, which gives Canonical the opportunity to apply those source updates to .NET in the Ubuntu archive. And then on Microsoft Patch Tuesday, which is the second Tuesday of every month, means that .NET can be updated everywhere simultaneously. Microsoft updates .NET in a number of places, and then Canonical will update .NET in the Ubuntu archive. Speaking of support, so developers can file issues in kind of the regular places. You can file issues in the .NET GitHub org. You can file issues in Launchpad, which is where they typically go for Ubuntu issues. And then if you're a company, you can get commercial support from Microsoft or Canonical, and you can make sure that everything is working correctly as you expect. Okay, let's move on to chiseled containers.
All right, thank you, Richard. So part of this collaboration involves chisel and creating containers for .NET. And before we actually start talking about .NET containers, I just wanted to do a quick introduction around chisel and why we do chisel and what chisel is. And here, basically, I just want to start from our usual perspective of what containers are and where they started. And those that are most familiar with the Ubuntu container image know that it is a general purpose container image. And more we know that these are not the ideal images for lean production environments. This is awesome for a development environment. It is awesome as a base stage for your build process. But ever since a few years ago, the districtless sort of strategy for building container images took over. And this is the ideal way to start building containers that are smaller, that are more secure and more fit for production. Now, with Chisel, if you have heard about the tool, it is something that we have developed inside Canonical to try to achieve a similar purpose, also a very minimalistic image, only with the things that you need for running your application in production, but that is coming from Ubuntu, built by Ubuntu, and it is acting as a sort of package manager for installing file systems that can be packaged as container images, and that in the end are as small as any other districtless-like or minimalistic container image that is meant for production. So then we start asking why we did it, right? Apart from the size, which is an obvious added value, there are obviously many gaps in today's offerings for containers. And obviously, one of the most concerning aspects of containers is security. Developers are concerned about security. And there's a study here that you can find the links at the bottom of the slide. They have done something very interesting. They have taken 20 of the most popular images from a container registry, and they also took 6 different vulnerability scanners. And when testing those 20 images, they came out with all different results across the board. Now, that's not that surprising because scanners work differently. They have different methods of detection. They have different compatibilities with different ecosystems. So amongst all the reasons we could find for having such discrepancy, we have different ecosystems, we have different compilers, different methods of detection. Some scanners rely on metadata that is contained inside the container image itself. One of the major things, one of the major concerns here are what we call false negatives, right? We know what false positives are, and those are usually driven by the way CVs are identified, but sometimes having a false positive is just that. You are not really exposed. You can justify the CVE and move on. A false negative is much more dangerous. It is a blind spot. It is about having something that you don't know you have, but that someone else can exploit. And one of the main causes for having false negatives that was identified here is the lack of a package manager when you are building your container image. Now, this takes us to rethinking containers, and this is one of the main causes and one of the main drivers for us to having developed Chisel. If we look at districtless today, the typical approach for doing it is by taking a base image. Even if you know the provenance, you trust that image, you tend to inflate it. You add all the dependencies, all the software, everything you need to run your application, and then you start cherry picking and trimming it down to a very minimal container image, right? The process, as you might get from my description, is top-down, and it is very error-prone because first you have to be the domain expert to know what to cherry pick from there, right? And you might unintentionally leave things out or put additional things in. So it's a very undeterministic process. And on the right side, the way to battle this strategy is to go the opposite way. We try to do things bottom up. This is the Chisel way, and it's managed. So Chisel, you can look at it as a sort of a smaller package manager. It doesn't handle packages. It handles slices of packages. The packages are the same ones you would find in Ubuntu archives. Those are Debian packages. And what Chisel does is a self-contained way of starting from scratch in building a partial Ubuntu file system by taking slices out of the Debian packages that we know. And Chisel acts as the manager in this process. So you will have all the information, all the metadata required about what's being installed in your file system. And the end result is still a very minimal image with a very low attack surface, but it is still as functional as any other image when it comes to running your application. So this is basically a drawing here about how Chisel works. It's trying to depict this all slicing idea. On the left side, you have Debian packages, right? And what Chisel does is that based on a declarative definition of what a slice is, it can basically go to those Debian packages And on your instruction, find portions of the Debian packages and install them in a new file system. So when you do something like chiseled cut, and then you say ---- root, the staging folder is actually empty, and you are telling Chisel that you only need the libs slice of the libc6 package, right? You don't need anything else. Slices can also have dependencies amongst them, so you can define all of that in advance, such that you don't need to cherry pick your final image during build time and after you have inflated your base image. No, here everything happens from scratch, bottom up. You predetermine what you want to have in your file system, and those are the slices that Chisel will install. So now going to .NET, and what does this mean for .NET developers? So we are trying to kind of create a full circle, a full story for the developer experience. And here we have a couple of screenshots. One is a blog from Richard here announcing the .NET chiseled containers. Canonical, we build our own Ubuntu-based chiseled .NET containers, while Microsoft does the same with Chisel as well. So you will find in MAR that there are a few containers that are chiseled, offering different flavors of .NET. And on the right side, we can see just a quick comparison of the different sizes for the same environment. So on the left side, we have Ubuntu.NET image, which is the full inflated Ubuntu-based image with .NET installed. And then with almost half its size, it's the same software, again, .NET, but chiseled on a chiseled base, right? And further on the right side, you can even go to 5 megabytes of size with a super minimal chiseled Ubuntu image that serves the purpose of running self-contained .NET applications. So if you are about to start building and packaging your applications in containers, your .NET applications, we have basically an offering shared between Microsoft and Canonical in several container registries, where you will find .NET 6, 7, 8 on several Ubuntu bases. You will find different images, whether you are targeting self-contained .NET applications. In that case, you can use the .NET depths. You will find the chiseled.NET runtime and chiseled.NET ASP.NET. So you can choose the one you prefer. You can also build your own. We can see that in the next slide. But ultimately, with the support for containers within .NET SDK, your whole building and packaging experience boils down to one single instruction. So the .NET SDK can publish your application in a container, and you can actually choose which container to use, either manually, as we are doing here in this example, by doing container-based image, or you can also use the container family, which will automatically pick one of Microsoft's chiseled containers automatically. So this is also something you can do, which is bring your own chiseled Ubuntu image. On the left side, you have an example of a slice definition. It's quite simple. All that matters is the package on top. It's the .NET Runtime 8, and then you can basically create as many slices as you want to. So when you create those slices, you are basically saying that, hey, I want a slice that only targets the libraries from .NET, another slice that maybe targets configuration files. Whatever it is, you are selecting the things that you need and leaving out everything else. So in the end, it's chisel cut, the package name, and then we have a convention that is underscore and the slice name. So there is a quick demo here. It's about 5 minutes. It's about depicting the whole full circle from source to deployment of a .NET application. So what we can see here at first, I'm just showing that I'm running this demo on 2404. It was done a few days ago, so not yet the official one that was released today. I'm also showing that I have .NET SDK 8.0 installed in this machine. Came from the archives, from the main archives, which means you will get free support for at least 5 years, and then you have the Ubuntu Pro. For the demo, we'll be using this demo application. I'm not going to talk too much about it, but basically it's a content management system that will give us some sort of visual feedback to the demo. And I'm going to use one of the core modules of this application. And I'm going to show you as well the project definition for this application, for this .NET application, just to show you that we have added a couple of things. First, we have added support for the container features on the SDK. And we have also defined in the project the container name that will come out of our compilation in our build process. We have also added a couple of environment variables that are useful for the application to run. And now all we need to do as a developer is just, again, as it was in the slide, .NET publish, and then we should note the -t publish container, which is what will make the SDK publish this in a container. We are using .NET 8. And here I am using on purpose our canonical image for .NET ASP.NET. This is a chiseled image that we have published in ACR 8.0 based on Noble. But we could also use, as I said before, the container family. Both options would work just fine. The latter, you would just need to pass something like noble-chiseled, and the SDK would automatically fetch the chiseled image from Microsoft's registry. So here we can see the build ongoing, and we are going to the last step here where we can see that we are building the image. That's the target image that we have defined in the project, and is being built on top of our ACR chiseled Ubuntu image for ASP.NET, right? And we got the final image here. We are going to quickly upload it to my own private registry, which is, by the way, it's my name, 𝗦𝗽𝗲𝗸𝗫𝗀𝗃. So while the upload is taking place, we'll just have a quick look inside the image to see what happened during the build. And we can actually see that there's an additional layer, the last one, where the whole application was added on top of the chiseled container image. And from the chiseled container image, we can see at user bin and user leave here that everything that is there is actually just .NET and its dependencies, nothing else. So the extra layer is really just the application. So here I have nothing running on this host on port 8080. So now I'm going to start a container just to make sure it is functional. So I don't need to pass anything apart the port mapping. The container seems to start well. I have it listening on port 8080. I'm going to go back to the same IP, refresh the page, and now we should get the landing setup page. I'm not going to start anything just yet. I'm going to leave that for later, because now the next step in our full circle of development is to actually deploy this somewhere. So I'm going to stop the local container. This was basically my naive test to make sure it works. I'm now going to show you that I have an AKS cluster. It is running, it is set just for this demo. I have a few nodes, a few Kubernetes nodes running there in Azure. And what I'm going to do is to actually deploy this container, attach a service to it, and then I'm going to rerun the same thing from the browser. This time we are going to do something with the application. But you can see here that the Kubernetes service is quite simple. Again, port 8080, and it is using the image that we have just uploaded to my private registry. So I have a couple of replicas. That's nothing to, it's just configuration. There's nothing special about it. And so we are going to go outside and we are going to apply this manifest. And while the container, the deployment, and the service are being created, I'm going to start getting the logs out of it, just so we can track the progress and see what's happening inside the application. We should see, hopefully, the same thing as before, and we do here. So in principle, our container is already listening on port 8080 again. Now all we need to do is just to get the service IP, the external IP, just so we can redo the same exercise as before, go to the browser, paste this IP there. So we open a new tab here. And again, we want port 8080. We should get the same landing page. And this time around, we are going to do a quick exercise, set up something, just create something from scratch here. So let's say the recipe is software as a service. We create a sample here. We don't care about the database, some email, some user, some password, just something random here. And we finish the setup. And we should get our sample page, which is just a skeleton, but it is running on AKS from a chiseled container image that we have built from the .NET SDK on 2404. And that's pretty much it for the demo. I'm going to give the presentation back to 𝗦𝗲𝗀𝗀𝗻.
Awesome. Thank you very much, Cristovao. Thank you, Richard, as well for this presentation today. And here are some links that can help you on your journey learning more about .NET on Ubuntu. So we have a blog post written by Richard where you can learn a little more about .NET on Ubuntu 2404. And we have some other links as well that are going to help you. They are all available on the description of this video. And if you have any questions related to the topic of this video, you can email us at azure@ubuntu.com. Remembering that this is not a support line, so this is more for questions. Thank you.